Hey everybody, I'm really excited about tonight's talk. What we're actually doing is called Lightning Talks. Wasn't sure what else to call it. What it actually is we had a sign-up sheet, so whoever in the group wanted to do a short presentation on any topic of their choice, about 20 minutes long each, they could present on anything that's interesting them within the field, something that they learned recently, something that just interests them, something they built, really anything at all they could present. So I was thinking, if you're ready, Joseph, Joseph is joining us, and he was going to cover a little bit of Docker for us.
Let me know if it gets bad. It
Okay.
should sound pretty good. Hey, I'm Joe. My sister's Gina.
Oh,
Um, I
yeah.
introduced her. Yeah, I showed her the meetup.
Uh-huh.
So let me share my screen real quick. And can you guys see it?
Yes, we can.
Awesome. Okay, so yeah, my name is Joseph Arahim. Gina's my sister. I'm a junior. Technically, engineering analyst is my role at Wells Fargo, but pretty much a web developer. And I just graduated from ASU actually a few months ago, and I actually learned Docker. I started a year and a half ago, and it's just been one of those things that I got introduced at this part-time job I had at ASU, and I was just like, let me see how I can get better at this and apply it to other things that were going on. And sorry, other things that I was doing, like academia. I was really into cybersecurity at the time. And, so I was just trying to figure out a way I could use Docker. I was using it at work, and usually when I'm using things in school or work, I take them home and I try to, get a little bit better at them. But so yeah, I'm gonna give you guys a quick intro to Docker. This is gonna be a very basic, if the things I'm not very experienced, and I would expect somebody who's not experienced to be able to do certain things with it. And so let's get started. And if you guys have any questions, just feel free to just jump in or just post in the chat. I can see the chat as well. And I don't know why this. There we go. Okay, so just a little overview of what I'm going to be covering. I'm going to cover what Docker is, why Docker, why. I don't know if everyone's heard of Docker. I heard it in school, and not a lot of people, and not a lot of the students heard it, but I assumed it was very popular. We're going to go over some Docker basics, pretty much, doing the very bare minimum that like somebody who's very new to Docker and you want to start using it for things that you do in your free time, or, even at work or whatever you want to use it for. This should at least get you going and start having fun with it. And then I might do a quick demo, I don't know, and then I'll answer any questions. So what is Docker? If you don't know what Docker is already, Docker is a big show you the website real quick. So if you just Docker has some really good documentation, but they're pretty much it's just a container, and think of it as a virtual machine. It's just a way to wrap software in an application, whatever your purpose is for it. And for web developers, it's like wrapping your application and deploying it. For me, and as a student and a learner. I download people's code off GitHub and I run it in Docker containers. Or when I was learning Linux, I download a Ubuntu image, which I'll go over later. But I would download, the operating system and be able to, learn from there. So just think of a container as just a place where you can. There's literally an operating system inside of it, and the operating system can depend on the distribution. But it's just a place where you can build and tear. And it's very, like I said, it's very similar to a virtual machine. And if you've ever worked with a virtual machine, the main difference, which I'm going to be going over in a little bit, but containers are very light. That's why everybody's using them right now. They're very light. They're very easy to use. So that's why they're very popular. And this is a little graph that shows how popular it's gone the last few years. Polls are just like if you use Git, when you pull something off Git, it's just very similar. When you pull someone's project off GitHub, this is doing the same thing. So people, when I go over the Docker Hub later, you'll see like MongoDB is on there, Ubuntu is on there, so you can pull these images and then build containers with them, and then do whatever you want with them. And I'll show some examples later. But essentially, what Docker solves is one of the first things that I learned when I had that part-time job was that if it's working on my machine, it's going to work on your machine. Before that, it was I had a Windows machine. Somebody else I was working with had a Mac. And, you know, 1 in a million person had a straight Ubuntu virtual machine. You know, so people had their own operating systems, and it would work on my machine. But then when I tried to get it to work on, you know, a friend's or a classmate's or whoever's, it wouldn't work. You know, because of their operating system. So this lets you containerize it, and anybody, as long as they can download Docker onto their machine, whether it's Linux, Windows, Mac OS, React OS, which is a Windows Linux hybrid, as long as it can download Docker and you can pull the image and build the container, it will work. Nothing will stop you. Another thing that it kind of solves, and I'm not really experienced with this, but apparently it helps with like legacy issues. If you have applications that you don't want to get updated or don't get updated, you know, you can package them up in these containers and just deploy them and not have to worry about them. But that maybe somebody more experienced can kind of explain that. I don't really understand that. And then like I said, another thing that's really cool about containers is they're really easy and light. Easy to spin up and very, very light. And this image right here actually kind of shows you what the difference is. And just know, when you look at these two images, starting from the bottom, infrastructure, that host OS on the left one, that Docker, the infrastructure is just pretty much your host machine. Or I guess it's the hardware, and then you have your host. But essentially, what this is just trying to show you is that with a VM, it actually eats away, takes away resources from your machine. So when you look at your computer, you have a motherboard, and on that motherboard, you have a CPU, which, you know, just runs instructions. You have RAM slots, which is your random access memory. That's where, you know, right now, as you know, you're watching this and listening, RAM is being accessed to do things. And then you have your hard drive, which is more of like long-term memory. So when you create a virtual machine, you actually taking these things away from your host machine. So if I want a virtual machine for Ubuntu to do a web development project on, and I set it to 10 gigabytes of hard drive space, and I set it to, you know, 8 gigs of RAM, and that when I run that virtual machine, it will take that away from my host machine. So I have on my PC right now, I have 32 gigabytes of RAM. So it takes away 8. So if on my laptop, I only have 8 gigabytes of RAM. So I can only allocate like 4. So that's what a VM does. It's a virtual machine. It's literally imitating a machine. What a container does, and this was like a really cool, like when I read this one sentence, I was like, oh, that makes sense now. So a virtual machine is trying to virtualize a machine. A Docker container is trying to virtualize the operating system. So if that, I don't know, that just kind of clicked in for me, and I kind of understand the difference a little bit more. But that's why they're lightweight. Containers only take what they want. So if you're running a project and it needs more RAM or more hard drive space than it did, it will just take what it needs as it gets there, which is really cool. So going on, and here's a little Docker intro. Let's see, what was I trying to... I know this doesn't really make sense if you don't know what Docker is, and I'm sorry, but a lot of this is, I tell my sister too when I go over these things, and I'm like, a lot of it is just repetition. Like, I just want to, you know, show it to you. Remember, you know, you hear the term container, you see that, you know, the word image. Just get used to seeing them, and hopefully, you know, it kind of just, you know, makes more sense as, hopefully by the end of this presentation, you're like, oh, I'm like a pro now, you know? So this is pretty much what Docker is, and at a very low level, you know, you got your server. This is just this part right here is their service. There's a place called Docker Hub. It's just like GitHub, where people, you know, post their, you know, their containers for other people to use. Like Ubuntu has their image up there. That you can use. But right here is where we start getting to. This is where you will be able to start to do some cool stuff. So here with your Docker client, and like I said, it's imitating your operating system and not your virtual machine, but anything that you would want to do in a development environment. So you have something called an image. Well, if you have any experience with, you know, if you're an experienced programmer, this is almost like a class and an instance, right? A class is the blueprint. You know, you tell it what it is, how it's going to do everything, you know, what it is. And then the instance is, you know, you make it alive. You make a copy of it that's actually existing. So an image is a class. Images get created into containers. They get ran into containers. You can also set up networking, and a big thing with Docker is you have, like, they call them microservices, but essentially is you have if you have a web application, like your front end would be in its own Docker container, and then your back end would be in its own Docker container, and then your database would be in its own Docker container. So that's what a microservice is, but it lets you network. So right now, if I spun up a container, a Ubuntu container, like I'm into cybersecurity, so I could do a penetration test on a vulnerable operating system. I could, learn, or I could just do development on theirs if I wanted to do. And by development, I mean by accessing local host. I can expose that on my host machine and be able to, see my work and not. And I guess another big plus about what it solves is that you don't have to download stuff onto your machine anymore, right? With a container, you can just throw it away when you're done. Like if I need to learn Python, I download a Python container. I learn what I need, or I do my development, and I just throw it away. I keep my host machine clean, and I'm very, very strict about that. And then we also have data volumes. So these are all the things that you'll be able to do with Docker. And I'm going to go over these just a little bit more. So images and containers, like I said, this is straight from their documentation. And honestly, I really do like their documentation. Actually, I think everyone is really doing a great job with documentation these days. So I tell my sister too, I'm like, go read their documentation and read it over and over again, because I spent countless nights, like when I go over the examples later, like I'll show you one that I used for one of my classes. This took me like a week and a half and I look at it now and I'm like, oh my God, this would have taken me like 30 minutes to build and get going. But it took me like a week and a half, like of literally like 6 hours a night, just like I was into it. But so an image is, straight from their mouths, is a read-only template with instructions for creating a Docker container. And I'll show you what that means. But just remember, it's a class. It's the blueprint to what essentially you want to use, and it's the container, the running instance of an image. And there it is right there. And you can create, start, stop, move these things, and I'll go over these commands later. And I did really like this image at the bottom. On the very left, that folder there is supposed to be the Docker file. I don't know why it's a folder, but it should be a file. And then you build the Docker file into an image, and then you have this image, this class essentially, that you can make a bunch of containers with, and then that's what a shipping container. So that's pretty cool. And this is the Docker Hub. So just like GitHub, where you can go to GitHub and look at people's code and download other people's code, contribute to. You can actually go to the Docker Hub. Where is it? Here it is. This is the main page for the Docker Hub, and this is actually pretty cool. If you go to Explore, you don't have to, I don't think you need to sign up actually, but right here, these are the most popular downloads. So Postgres, I've never used it. I'll try to hit up the ones that I know, like Mongo. Actually, don't use that one. That one wasn't fun. But Ubuntu is one that I use all the time. Node is one that I use all the time. BusyBox is a very lightweight. Alpine is also another lightweight operating system that people use. So they will, you do your development on these images and add whatever you can, customize them. You need Node installed, you add Node. You need Apache running or whatever you need, you can do that. But I really love this because I would come here and whatever I was learning in school or whatever I was learning on the internet too, it just made it easier, because a lot of tutorials, they'll do them on Ubuntu, or it'll be on Mac OS or whatever, and I'm on a Windows machine, and it's just the installation becomes it becomes an obstacle, and it kind of like impedes my learning, So that's what I really liked about this, and that's a thing that itself. Nginx is I think it's like a web host. I don't know what that is actually. I know Apache is, but anyways, so that's what the Docker Hub is. It's just a place for you to pull. I could pull their images onto my computer, and I could do stuff with there. You could push stuff up there, and people can pull your stuff down if you set it that way. And that's where I've been doing my development at Wells Fargo, and the last job I had before that, which was at ASU. We were using Docker. So, and these are some basic Docker commands. Don't worry about these too much, but just know this is how you would build a Docker container. I hope you guys can see this. But this is how you would build a Docker container, and then this is how you would share Docker pull. But I'll go over a quick demo and show you guys this. But a big one is how you would run the container. you would just do Docker, container run, and then give it a name, and then the name of the container. Oh yeah, there it is right there. This is and I'll go over this later, but the -p flag means port. So you're exposing a certain port on the container to the host. I forgot which way it is, but and then this is the image. But very basic. Just even to get started, you don't need to know that many commands. And this is the Docker file. Sorry, hold on. I just noticed that there was messages. What do you need to know before using Docker? Honestly, nothing. I would say. I think you get started with Docker. I think if you have something that you know that you could use it for, like at the time, I guess I can talk about that story now. So at the time when I was trying to get good with Docker, I was actually taking a pretty tough class at ASU, and I was writing this code in C++ or something. I don't remember what it was, like C or C++, and I was stuck with this bug, and I couldn't solve it. It was spring break. It was the Monday of spring break, and this was like last year. CSC 340. I forgot his name. I don't know. I'll show you, and maybe you guys will be able to tell me what you think that somebody would need to know. I told my sister, I think my sister would be able to, if I showed her this, I think she'd be able to get started pretty quickly on this. So not much experience at all. But it was CSC 340, and it was one of his projects, and so I had this bug, and I didn't use a debugger at the time, and I was just using print statements. So it was spring break, and he had office hours. So during spring break, which was crazy, the assignment was due like the next day or something. But I went to go see the professor, and I was there for 7 hours with this guy, and he's the professor. He should have been able to figure out the what the problem was instantly. Like it's not like I went a different route with the go. Nothing on him or anything, but it was just crazy to me. And the whole time I was there, I was like, man, I wonder what would happen if I had a debugger, ready, and I could just fix, because we were just doing print statements and nothing was working. We didn't know what it was. 7 hours later, I go home. I literally I get, I don't think I get use Docker, but I got a debugger going, and then after I figured out what my issue was within like 10 minutes, and I just sat there and I was like, I couldn't believe I spent all that time. I could have literally came home, downloaded the tool, had figured it out, just been hanging out, playing video games, whatever I would have been doing that day. So then I was like, you know what, I'm gonna create a Docker file. And that's the cool thing about Docker containers, that they can do whatever you want them. If you want one that is managing your database, that's cool. You can have that. If you want one to use as an operating system like Ubuntu, cool. You can do that too. You can download vulnerable applications in Docker containers and use those to learn from. You can download, I don't know why I said vulnerable. You can download people's applications and use them. So, like I said, I created this Docker container. It's not this one right here, and I'll show you guys maybe in a minute. But I created it, and what happened from then on is every time I wrote my code for that project, is I would anytime I came across an issue that I needed to debug, I wrote a Docker container that essentially had a debugger inside of it, and I would pass it my code. And then it would run the code, and I would just execute through the debugger and figure out what my issue was. That's all I built it for, and it was very basic, but it served its purpose, and that's what pretty much containers do. They just do something, so you can use them for whatever you want. And this is the building block of all Docker containers. They all have Docker files. So the one on the left is a very basic Docker file. You would literally just have a file called Docker file. I don't even think it needs to be capitalized. And you definitely, the only thing you need, I think, is the from. You don't need anything else there. You need a base image. Every Docker container has a base image, whether it's Alpine or that Ubuntu or Python, whatever it is. There's a base image there. I would say CodePen has its place for I definitely pop open CodePen for small little things I'm trying to experiment with, but for tutorials and stuff like that, I actually will pop open a Docker container. Or lately I've been using virtual machines, but inside of my virtual machine I have Docker running, because there's just a weird thing that's happening on my computer right now. But I definitely, Docker has its place, and I'm not saying you should be using it for everything. Like I pop open CodePen, JS Fiddle all the time just to do, quick things and languages that I'm trying to learn or whatever I'm trying to do. This one is a little bit more advanced, but let me just go over these commands real quick. This is copying, if you don't know what the dot means, and it means your current directory, so it's copying everything in your current directory when you build this into the container app called, in the container folder app, and then it's just running make, it's just creating an executable, and then it's going to execute this command Python and run this application. Very simple. This is the same thing. This base image is Python. The working directory is probably the directory that you're going to open up in. And same thing, you're copying all the work, your files from your host machine to wherever you want on the container. This is where you can customize your container. You can run certain things. You need, like, for my container, I installed GDB, whatever I needed, Vim, because I'd pop open my my program, my binary, and make changes, and then rerun it in GDB. GDB is a debugger. So then I would just, I had all my tools that I needed inside of my container, and that was it. I didn't have to, run the container and then do, install this and stuff. You can do it all here, and then when you build it, you can just run them, and then they're already ready. This is just making the port available to the world, environment variables, and then this is the command that's going to run when it executes. So that's what a Docker file is. I wouldn't expect anyone who's getting started with Docker to be able to do, to build, but it is very easy. If you go to the documentation and follow their steps, you could build your own simple, your own custom Docker container. Or I guess I would say Docker file and an image. Let's see. So I guess I can do just a really quick demo. And like I said, I would just expect somebody to be able to, like, pull something. Like if you were working with somebody on a team and they had an image, like at that first job I had at ASU, we had a Docker container, and I had to pull that and onto my computer and run that, and that was our environment. And and it gave us all the ability to work on the same environment regardless of our host machine. So you should be able to pull something on your computer, and you should also be able to run it. I wanted to do like build, but I would say that's more of like a level 2, like a level 2, level 3 kind of thing out of 5. But this is what I would expect somebody who's very new, not very experienced, to be able to pick up pretty quickly. And by pretty quickly, I mean, like, in a week, 2 weeks, and be able to get going with, and especially at a probably even just basic pace, And this is me. I've been using this for a while now, and like now I can find there's use cases where I find for VMs. Oh, I'm sorry. Yeah, there is a question. I mean, so with the Docker container, which you're about to see right now, let me show you. You don't get a UI. So if you're not a command line person, you're not, I hope I can make this bigger. No. I hope everyone can see that. But I've been using VMs because you get the graphic, you have the graphic, the GUI stuff, everything's here. But Docker I haven't recently. Last time I used Docker was when I was pen testing an application. But there's definitely times when VMs are going to be better for over Docker, and there's going to be times where Docker is better than a VM. And I don't know. I guess it's just going to be kind of depend on what you're trying to do. If you're just running. I'll show you a quick example right now, actually. So one of the examples I used to show to my friends because they were into cybersecurity as well was damn vulnerable web application. Oops, Docker. So, and I haven't done this in a long time, actually. So if this doesn't work, I'm gonna be embarrassing. So one of the very basic commands that you're gonna have to learn. So after you have everything installed, you can do docker ps, sudo docker ps. And docker ps lists all your containers that you'll have out. Right now I have none running. One of the first ones that if you go to their documentation and they'll have you run is, you can do docker run hello world. I'm gonna do sudo. So what I just did now, I ran docker run hello world. This is after I have Docker installed, right? What Docker does with run is that it looks on my computer. It's looking, it's saying, hey, do I already have an image called Docker or hello world? I don't. So then what it does in the background, actually, I think it explains it right here. Hey, this is a message that shows the installation is working correctly. This worked because Docker took the following steps. The Docker client contacted the Docker daemon, and then the Docker daemon pulled the hello world image from the Docker hub, and then the Docker daemon created a new container from the image, and then it just explains everything. And so that's how you can tell it's working. And then from here, I'll take it one step further, and this is a vulnerable web application called DVWA. This was something that I showed my old cybersecurity club. This was something kind of cool, and just as a small example, I'm sure there's hundreds of other examples, maybe even thousands on Docker Hub that you can just do like this. There we go. So I'm gonna pull this vulnerable web application, I'm gonna run it, and I hope it's gonna work the way I want, and then I'll be able to show you guys how I have like a vulnerable application running, and you can use this for other applications that you see. You could be on here and see a project like, oh, that looks cool, and then run it with Docker if they have a Docker container for it already. So, and like I said, if you go to the Docker Hub, all these people have created, and there's, this very popular, everyone has them. Like this is a popular one that I use all the time for Docker. When I was taking a system security class at ASU, our professor was constantly using Ubuntu, and he was just doing all this crazy stuff up there. I was on a Mac, but I would just open up a Docker container and just do everything he was doing, all the commands that he was doing, and just follow along that way, instead of, installing a virtual machine, which, would have taken longer, or boggled down my MacBook, and I didn't want it to die, or whatever the reasoning was. At that time I didn't need anything full fledged, for me, and I was trying to kind of get better at the command line. So let me see if I can get this running. It should actually. What's cool about some of these projects will actually give you give you instructions on how to run it. There we go. So what I did already was we pulled this image from the Docker Hub, this web DVWA, and oops. And now I'm going to run it. And what should happen is when I run this, I should be able to access this application now. So now that this container is running an application, and it should be hosting it on port 80. And now, I don't know, I don't think that will work. I should have changed the the port. Local host, right? 80 is not going to work. Oh, there we go. Yeah, actually it does. For some reason, I thought 80 was going to, I always change it like 8080 or something, but here you can do admin. This is supposed to be like represent like a bad application. This is kind of cool for you guys to see too, because when you write code for, your applications, if they're web-based, this is how people try to break into them. They just use generic stuff like this. So I just used admin password. And this is a full-fledged learning tool for people, for cybersecurity people. So you can come in here, you can get set up, you can learn about different stuff, but this can apply to whatever you want to learn. Like somebody can have something already built out there for you to use, or an application exists on there. Another example I can show real quick is if I want to do, let's say a Ubuntu, let's say I'm back in that class again, and somebody's, somebody's talking about file systems in Ubuntu, and I don't know what they're talking about, and I would like to, follow along. I go to the Docker Hub. I already know what it is, but I would just do Docker pull Ubuntu. Oops. And what it's doing now is it's pulling the latest image from the Docker Hub, and now I have an operating system of Ubuntu on my computer. And actually, I forgot to show you guys this. Docker images will show you all your images, kind of, they're all your classes. So I have a Ubuntu, I have a Hello World, and that damn vulnerable web application. And now if I want to run Ubuntu, I can do Docker run, and you can give it a name. Just keep it simple. Docker run, and then the name of the image or the repository. I guess they have it listed here, but the image name. Oops, I forgot. I made a big noob mistake. I forgot to put one flag in here that you're actually going to want to run. Usually when the application is running, it'll just run in the background sometimes. That's what happened there. There is, let me show you this. There is actually a Docker container right now running. Is just I didn't add a flag in to make it interactive. So if I show you PS, oh, did it not run? Okay, so this is it right here. But what I need to do is Docker run Ubuntu, and I need to do -it for interactive, or and then TTY or something. But now it's gonna, oops, sorry. Docker. There we go. So now I am actually in a container running. Instead of it running and serving something to me and being able to access it, I'm inside of a container right now, and this is specifically a Ubuntu, and I think it's going to be a 2004 version. But if I go to, yeah, there we go. So you can see here, it's a Ubuntu machine. It's a version 2004. It's Debian based. Everything about this you can see here. If I was to download another like a Python one, it would give you something a little bit different. It might be Alpine based, or there's different ones out there. But that's kind of what I used it for, and I hope you guys learned something. Now let me see if there's anything else on the slides. Pull images, run images. Is there any other questions that you guys had about that? Yeah, I think that's it.
So Joseph, if I have a Mac and I wanted to do something on Windows, I could just use a Docker container and do the Windows application that way?
So one thing that is kind of funky between the operating systems is the networking. So like if you're working on like a web application, like so on a Linux-based machine like this, I can start a container and be able to expose ports and access it from my host machine. But if you wanted to do that on a Windows machine, I think you have to go through a little bit more hoops, but I'm not 100% sure. I do remember, because I had a Mac, and I was constantly working between my Windows machine and my Mac, and that was definitely one thing that I noticed, that on my Mac it was very easy to set up a container and start like the networking, because I wasn't very experienced with networking. And it was a little bit easier to work with. On the Windows machine, I think I had to go through a little bit more hoops to be able to expose ports and do stuff like that. But yeah, if you get it working in the container and set it up in a way where it's, just like how that application is set up, the damn vulnerable web application, this will run anywhere. If I download this actually onto my host machine and run it on Docker, it will run the exact same way.
Cool, thank you.
Yeah, no problem. Any other questions? All right. Thank you.
Thank you. That was a really awesome presentation. Yeah, I had a general idea and I understood the containers, but that was really great. Thank you so much.
But basically, what I'm here to talk to you about today is GraphQL. GraphQL is a schema-like language that's used to peruse data. So it's different than JSON coming back from REST. Just a little bit about it. It's like, you normally have JSON like packaged up in one big payload from various different endpoints. But the problem is the front end would always have to stitch everything together to be in the format that it needs to have. So if you're front end like, React or just vanilla JavaScript or Vue, whatever you're using, even though it's getting the things from the API, it still has to make the JSON fit into an object that'll work for that component. So what GraphQL was supposed to do is munge all of the data into that format already for you. So it's like a separate server that knows when to call certain REST APIs if you need to, or you could just build it as your, you could build it into your server-side application. So like maybe if you have, we actually used Graphene, which is a Python library for GraphQL, so we didn't have to have like a pass-through because our backend is written in Python. So instead of getting everything, you could also just get certain pieces that you want. So if you only want the tagline, when you format the request body, basically I could say, I just want the tagline, and it'll give you this. But you could actually ask for everything you want. Like I could just say name and contributors, and then whoop, the JSON will give me exactly what I want. So it's really great for the front end people. So here were some issues with it. Well, I guess before I move on, I will go ahead and kind of show you that a little sample of what we would do. So this was for creating a product, and I'm sorry, this is like really tiny. I wish I could zoom in. If anybody can tell me how to zoom in on this thing. I didn't realize I made it with such a large screen. But basically, we had so many different attributes. We had clearance attributes. We had basically like, so our whole business is based around putting items into rooms and knowing where things are going to spatially conflict or not, and that's usually up to the planner. So having these attributes like what electrical hookups there are and all these things, it's just massive amounts of fields. So we were running Python, and we also had our GraphQL service at the same time. And we normally make, in a normal REST API implementation, instead of GraphQL, we would, have a given endpoint. Like, in Postman, we have, actually I can go ahead and log in here. I can get a response. I don't have it running right now. But an example for creating a product, just so we can see the difference. And I have some dummy data in here, but yeah, the model name would be like, refrigerator 415 or something. And, you've got the long description, the manufacturer ID, lots of different attributes to get a specified SKU. And you can, this is to create one, but you can actually use GraphQL to create resources as well. So here, without further ado, I will run this, and I wish it was larger, but look at the sheer amount of, here I'm just gonna like pause it for a second. If I can increase the size at all, it would be great. I can control this with the scroll button. Maybe that's a little better, I don't know. But basically, like, you got clearance attributes, electrical attributes, feature attributes. When we were getting everything under the sun, and we were putting that into this request. And so, here's like the amount of inches for the back, the bottom, the right, the front of for all the clearances, when it was discontinued. Mutation, this was technically in GraphQL, it's called a mutation instead of a post in REST API land. And so anyway, I'm just gonna go ahead and run it. And I mean, this is what came back from it. Like I basically can say down here, if I just want the okay and errors, but for the sake of showing it off during that particular time, I was basically saying like, I want to give me everything so I can see that everything actually got into the database. And you can see on the right-hand side all the debug statements where it's actually inserting all of these things into the database. There's a lot of revisions. That's just kind of part of there's like a library that gives you feedback about things. But above, if I scroll back a little bit, yeah, so you can see, it's inserting a lot of these attributes. The problem with all of this is not the format that comes back. It's beautiful. It really is. It's truly a marvel. But what we were running into is actually each one of these pieces and fields isn't in the most optimized format that you would get back from the database, period. Like, what we were running into is if we had like a list of products, which I was also trying to find, because I think I had another QuickTime movie of that back in the day. And certain products needed to be filtered out so that other organizations didn't see it. And then also, the other issue that we had was we have permissions. So there wasn't any concept of permissions at the time that we tried to do this. I don't know if that's been changed since then or not. But in REST API land, you can say, I want a whole, like an entire endpoint to only be able to be accessed by certain scopes. So, so if I had a scope, I don't have an example right at this moment. Actually, I'll give you an example. And this may be a little bit high level for some of you that are completely new to coding, but basically, so I wanted to, so I can get contacted here. So just make sure I'm. Oh, Carolyn's posting. Oh, what's the Zoom link for the meetup? Let me grab the Zoom link for Carolyn. She's trying to get in.
Or I think Violet just responded.
You got it, Haley? Okay, thanks. Cool.
Yeah. Neither of you have to get it because I already posted.
Awesome. Yeah. Sorry. Users. That's right. Okay, I can go to my profile. That'll work. See how much I've used this apparently. This part of the application. Okay, so these are like scopes that are limited to things. So I can only, as this type of, if I only have the basics, I can only read a category, I can only read organization resources, and I can read products. But I don't want certain, maybe I don't want somebody to be able to create a product because they don't have, maybe they're a free tier or something like that. So that was where it really broke down because with REST, if you're creating I guess I already closed it, but oh yeah. So if I'm doing a post to a products, I can actually say only these certain people who are opt with this certain scope of product create are allowed to make this call and have it come back with something tangible. Like it's actually, put into the database and saved. The problem with GraphQL is that it didn't have that feature, and it wasn't really ready for that. And we were kind of on that bleeding edge at the time. And it turns out we were just using it totally wrong, because if you look at the best practices, it says GraphQL is designed in a way that allows you to write clean code on the server where every field on every type has a focused single-purpose function for resolving that value. However, without additional consideration, a naive GraphQL service, i.e. us, can be very chatty or repeatedly load data from your databases. So whenever we would load, products, for example, like a list, it would get a product for every single ID. So it was hitting our REST API 50 different times. So because it was basically saying, okay, I need a page worth, and I need to get up to 50 products for this page. And then the next page would be another 50 products. And so it was getting every single ID instead of, and it was like resolving each one with REST API call to that detail, basically, instead of getting it all in one go. So if you can get all of the data at once, it's a lot faster. It's not as hard in your database, and that would have been better. I guess this is commonly solved by the batching technique, where multiple requests for data from a backend are collected over a short period of time and then dispatched in a single request to an underlying database or microservice by using a tool like Facebook's data loader. I'm not sure how long data loader has been around. I guess we were looking into this, but the problem with, I remember this. Yeah, the reason why we couldn't just use data loader to solve this issue is because basically it was saying if it's the same exact query that is being run, then it would only run it once. Now that doesn't work if you're trying to get 50 different IDs. That's technically a different body for each REST API call for each ID. So that wasn't really very helpful. I mean, it helped with something, but it didn't help with this particular problem. Now, the other thing is Graphene, which is, I think, GraphQL Python. We were using a very custom library for Graphene that wouldn't, because we didn't want to use Relay. We had tried to use GraphQL without Relay originally, and it would cause too much rewrite to actually use this middleware layer, which basically says, hey, component, here's where you will always get your data from. Now, I don't even know that if that's actually a good idea to have the component always fetch its resources every single time instead of having it on one particular page load. And if multiple components use the same data from the same API call, that's where Relay breaks down a little bit. But it's still a really cool library, and we couldn't use Graphene as it was because of the its dependence on Relay at the time. And so we ended up using something else, Graphene without Relay. I forget what it was called. Actually, yeah, I remember it. Amigo. I was trying to actually work with this guy. So we were back when we were trying to do. I should have followed him. Oh, fuck. Never mind. I'll log in later. But he's in Spain, and I was really excited. We were using Graphene Django Extras, which I guess it's still going. Wow. Without Relay. So basically, he was trying to get this going, and we were using Django under the hood, and instead of GraphQL, having a GraphQL server that was using the REST API calls for each and every one, we were using this implementation. Now, what was scary about all this, I guess what was scary about all this is not that it wasn't well thought out, because it was definitely really fun to use. I mean, I really enjoyed this part of my career, I guess. But we weren't sure if it was going to stick around. I mean, we didn't know if he was just going to rewrite the entire thing. I mean, it was just one guy that was maintaining this whole thing. So, and that's kind of a risk if you're trying to build a platform. I mean, yeah, I mean, this guy works day and night, and that's part of his, like, basically a master's degree program. So I think what was the end all be all was that we really had to have very specific permissions to access certain things, and we really couldn't implement it with this library. So we stripped out everything that was graphene related, and that was a major rewrite, but it was worth it because we had the functionality restored to limit down certain endpoints to only the users that were allowed to use them. And if you don't know anything about REST APIs even, well, don't worry about anything I said. It's really exciting. Both GraphQL and REST APIs are, I think they're here to stay because GitHub uses GraphQL under the hood. If you ever want to try to practice with REST APIs, I recommend using Postman. And also there's a really cool, you can actually like work with the GraphQL, GitHub API. If you ever want to learn it and see like the difference between things, there's really cool docs here. And yeah, they haven't switched back to REST API, so it could be that. Oh, wait, maybe they do have a REST API. They only had GraphQL last time I looked. So maybe that's changed. So I don't know. In the race between REST and GraphQL, we'll see what happens. But I will be there with the popcorn. All right, I'm gonna check the chat.
That's awesome, Anna. It's nice to see like how other developers think through it. It's not always easy to decide which route to go. And yeah, thanks for sharing that. Yeah, if anyone had questions there, I didn't check the chat either. Yeah, Lauren was just asking if there's any other way to implement authorization for data queries. Oh, she can't imagine that's a new issue.
So yeah, the authorization, or I guess, yeah. So I guess really the underlying REST API calls is where you would actually lock it down. But I mean, they might have gotten more server side, you know, in the past few years since we last used it. So it's a good question. Oh, why did it jump? Sorry. Authorization. Only authors can see their drafts to the business logic layer. So maybe it's improved since we last used it. So this is like an example. Okay, GraphQL object type. Man, it's been forever since I've looked at this. Yeah, we rewrote everything in JavaScript originally as like a, yeah, so it said the business logic layer is not in GraphQL. It's tempting to put it into the GraphQL layer, but this is, anything that's in your business logic layer is going to be REST API based, because basically they're saying, or, well, I guess, you know, it could be a processor or something like that. It doesn't have to be REST. But basically, our business logic was all in a REST API. But GraphQL isn't really built to handle this business logic. So it's only going to pull back what is limited. There's got to be another system here, basically. Whether that's Django or, you know, it could be Ruby. It could be anything, actually. And our REST API is using basically the ORM is its business logic layer with any other requirements that we add to that. Basically, that's how that's working. But GraphQL is not used to that. So it's saying like your GraphQL shouldn't have any business logic related to authorization. So yeah, I guess that's the answer. It's really just meant for the presentation layer. So doing it all, I guess maybe the headers. I don't know how you would resolve the headers. You could still probably resolve the headers somehow, but yeah, I guess I don't know. It's a really good question. But I guess if I go back, maybe they have a different way to do this. For a production code base, delegate authorization logic to the business logic layer. And it requires the caller to provide a user object. Using GraphQL JS, the user object should be populated with context argument or the value. Passing for you.
I love the language fully hydrated user.
Yeah, that means that you have all of the pieces of all the fields in there, but not just like a partial amount. You know how you can do like just a tagline for a product, but you can also get like the model ID and all those different fields. Well, they said like basically get all the fields for your user because you need to use all the pieces of it to make sure that your authorization's good. I like that word too. We use that at work for rehydrating Elasticsearch. So we talk about like getting all of the fields populated into our Elasticsearch version of all of the data. So Elasticsearch has like a big JSON document with all of our information about that product and various things to search by. So that's another place that word's used. Okay, yeah, it says defining authorization logic inside the resolver is fine when learning GraphQL or prototyping. However, you can't do that in a production case. Boo!
So what would you say is like the best feature of GraphQL? The most useful feature?
It is so gorgeous. It's just like all of the...
Pretty.
It's so pretty. Oh man, I really wish I still had it running because GraphQL. What did I use? It was like a really awesome version of Postman. It's like Postman query query application. GraphQL clients. There we go. Oh. Is this an example? That would be awesome. Oh, no, of course not. It's localhost stuff. Hello. I was hoping that there would be like a little example of. I guess I showed it in the thing, but I really liked this GraphQL client. I wanted to see an example, guys, not a document. Oh, Apollo, here we go. Maybe. Anyway, sorry, I can't find it, but yeah, no, it's just all of the things that you have to worry about with, like, say, formatting, like dates and things like that. Maybe you'd use like moment.js or cache values, things like that. Like all of those pieces would be handled in one spot versus having to write that logic a billion times in your application. So it cut down a lot of copy-pasted code to try to get the data more from, like, say, a Linux epoch timestamp to, a human readable format of that date time. That's a good example. Also like capitalization if you need it, or choices were really cool. The field choices for Django were automatically populated. So whenever you would set up your GraphQL query, you could basically, when you were typing in that client, it would pop up with a choice. If it knew it was a choice field, it knew what every single field type was. And it was kind of like you were doing TypeScript in a way, but around your requests in a way. And so that was really fun. It was like you had a fully integrated IDE to know exactly how your request was supposed to be formed. It basically was like Swagger on crack. So if anybody's used Swagger for REST APIs, that's really cool. It kind of shows you all the documentation, but I guess by having all the types already built in, it was self-documenting. So like over here, you could click the product create field, or product update, or supplier product create, all these different ones. This is all we had at the time. And you could click each one and it would show you all the different pieces that you could use. So like what each, back in inches, it would have the help text of what type of unit it was. And that was just so cool. Like, what was not cool was trying to, every time you'd make a change in your REST API, you'd have to go and make a change in your presentation layer GraphQL server. So that was also a challenge, but it was so pretty. I didn't have to keep rewriting things.
Great, thanks.
Yeah. Anything else? I think that was kind of a long one. Nope. All right. Once, going twice. And hand it over to someone else.
Sweet. Thanks, Anna. That was really awesome. Yeah, GraphQL is something I've never looked at, and now I'm curious to read a little more of the documentation.
It's fun, yeah.
Yeah. All right, cool. So next I was thinking, if you're ready, Chrissy, are you ready to? Okay, cool. So Chrissy's going to do a little bit about lifting state in React. So I'm really excited to hear about it.
Yeah. Can I share my screen so that I can show you? I have like a little diagram.
Absolutely. You should have permissions to be able to. I think everybody should be able
okay.
to.
Okay.
Yes. Yep, you can see it.
All right, so it looks like you guys can see it. So this is lifting state up. This is an article in the React docs. And so if you just go to reactjs.org, it's over here on the right with under the main concepts. So here's how this document works. So I was in the library before the pandemic, and I remember walking past the tech books, and it said like Mac OS, the missing manual. And so I thought for this document, it's missing a diagram, and it's missing a visual representation of what's happening. So so this is the parent component, and it's the calculator, and it's holding the state of the then the state is based on input right here. So a user would put in let's say like 20 degrees Celsius, and this function is hooked into here, this property on change, and it would take that temperature and decide through the boiling verdict if it's boiling or not. And so this is the boiling verdict. It's its child component of calculator. And the way that React works in general is that, move this over here and move it like this. Data and functions and everything moves downward throughout, from the parent component to the children to the grandchildren components. It's not like other front-end frameworks such as Angular, where it goes both ways. Data only flows downward. And because of that, when you start to add more components, you start to run into problems. So I'm going to get rid of this. Okay. Let me. All right, so I'm just going to move it off to the side because I can't really get rid of it. So in this document, so here's where they're talking about the boiling verdict. This is the child component. And in the parent component calculator, it sits inside of it. And this prop, the prop Celsius, it's getting that from temperature, which is up here from this state. It's declared here from the calculator's state. Okay, does anyone have any questions about that before I keep going? Okay, I'll keep going. So the next thing it wants to do, it wants to add a second input. It says that, you know what, let's not just have Celsius, let's also have Fahrenheit. So I'm gonna move this over. Okay, so I've got this, and I'm gonna see if I can cut it and paste it. Okay. And then I'll do the other one. Oops. I pressed the wrong button. And here. Okay, so this isn't quite as I want it to be because they're all like really wide, but I'm gonna do here. Okay, so now what's happening is now it has 3 children instead of the one before. And actually in this, it talks about, the document talks about extraction. So in React, every component only does one thing. So right here, we're gonna take out, what it does is it takes this part out and it moves it down to these 2 child components. One is for Celsius and one's for Fahrenheit, and they're both called temperature input, and they're both basically the same thing. The state temperature is held here, the handle change function is here, and the input is moved down here. And the way that it looks in the actual coding, this is the temperature input, so the function's here, and the inputs here in the rendering. And now in the calculator parent, it's showing the 2 different components, the child components. But we're gonna run into a problem. And the problem is that, remember how information has to go and data, everything is going downward. So what happens is if a user is inputting like 50 degrees Celsius, how is the boiling verdict supposed to get that? Information doesn't go laterally. It only goes from the top component, the parent component, down to the child component. So what has to happen is that we have to move the state up to the parent component so that it can be moved down. Okay, even though we just cut this out, we're gonna have to put it back up into calculator. So, so what I'm gonna do is I'm gonna keep the input here, but I'm gonna move this up to calculator. This isn't the most user-friendly thing. Okay. Okay, so that's been moved up. And then I cut this out here because it's no longer needed. Okay, so I have the input, What I'm gonna do now is pass this function handle change down as a prop. So this would be prop, or this, oops, this is bold. Okay, it's still bold. Unchange. And that's going to be this handle change up here. Okay. Sorry, I got distracted because my cell phone rang and my husband answered it. Okay, this is actually going to be not unchange, it's going to be temperature change. and try to unbook this. Okay, so that's something that's being passed down from calculator down to the children. And the way that it looks in the actual code, and I'm not going to worry about these extra functions, this stuff. I'm just focusing on where the state is being lifted up. So now, so this is how it looks here. It says, okay, so this is how it looked before, and this is how it's going to change. It's going to change from this state temperature to this props temperature. So let me just make sure I have that. I don't think I have that. And that's that props temperature is being brought down from the parent's state down to here, and it's coming also down here. So I'm going to copy this. Make sure that this component has it. Okay, so now both the function, this props on temperature change, is being passed down, and the actual state value from here is being passed down as a prop. Okay, does anyone have questions about that so far? I'm going to keep going. So that's what they're talking about here, how that changes from this state temperature to this props temperature, and how the handle change function is actually changed to this props from temperature change. And so this just kind of, oops, can you still see it? Okay.
Yeah, we can.
Yeah, my screen, the screen kind of blanks out a little bit sometimes, so mine went blank.
Oh, no, it's good for us.
Okay, okay, great. So this is how they refactored the calculator, the parent component. So they moved two things. This handle, okay, so they actually changed the handle temperature change differently. They divided it into two separate functions. They said, we're going to have one function for Celsius and one function for Fahrenheit. And above in the document, they go over some extra functions to convert between the two. And so this binding thing, this is something that happens related to JavaScript and this, because this is a class and you have to bind it, but that's kind of beyond the scope of this. So now what this is rendering, it's rendering the two inputs, the temperature input for Celsius, the temperature input for Fahrenheit, and the boiling verdict. So let me go back to this, and this is going to be different. This is going to be, there's going to be a function for handle Celsius change, and then there's going to be one for handle Fahrenheit. Okay, so those two functions were mentioned here, and they're basically setting the state. So all the state, every time a user would go and input Fahrenheit, they would actually, you can't see it here, but you'd have to actually go back to the temperature input component, which is up here. And anytime they change the temperature here, that actually is handled in the parent component calculator, and then the state of the temperature and the scale is also changed. So I need to add that. I'm gonna do this. I'm gonna make it a little bit more clear. And then the scale. They have theirs automatically set to Celsius. Okay. So there's two state variables, temperature and scale, and then just make it that fit. Okay. So they have the two state variables here, and then they have those two functions. Those two functions, this gets pushed down, the Celsius change gets pushed down here, and the Fahrenheit gets pushed down on here. It gets pushed down by something called its props. So everything that's in here in purple, these are all the props of the component temperature input. So the scale is C, the temperature Celsius is coming up from the calculator parent component, and then here, this function is also coming from the parent component, and Fahrenheit for Fahrenheit. The reason why this is still Celsius, it's because of the way that the helper functions were converting everything, so you don't actually need to change that. It's okay for this to be set in Celsius because of the way everything's converting. So here, a user makes a change to Celsius, it's actually recorded and changed up here, and then it's passed down to boiling verdict. And all boiling verdict does is display whether it's boiling or not. So if someone put in for Celsius, 50 degrees Celsius, it's going to say not. It's going to actually be stored up here and then be pushed downward as a property, not. And then if someone enters something in here in Fahrenheit, that's changed up here in the state for the temperature in the scale. And then it would change to boiling or not based on the verdict. Here, there's a lot of text here, and hopefully I saved you some, a little bit of mental energy because that's a lot to read. But this is basically how it looks as it's rendered. So they're entering either in Fahrenheit or Celsius, and this is under the hood where everything is stored and what's happening, how it's changing in real time. Okay, so basically, anytime you add a new component or add more complexity, you might have to lift up the state to the nearest higher ancestor, and that's because in React, information moves downward, and in React, they only want each component to do one thing. So here, it's inputting the Celsius temperature. Here, it's inputting the Fahrenheit temperature. Here, it's saying whether it's boiling or not. And here is where all those children components are being held. So, okay, do you guys have any questions? Any questions?
Just him.
Are you hearing my dog growl?
I heard that.
She doesn't like questions, I guess. Any questions at all? Any thoughts?
I really liked that you gave visuals.
Put that into more of like a logical context and visualized it, because I have trouble understanding it if, without like some sort of visual sometimes, and
Yeah.
that helped me so much. I feel like if I had seen this before I started building with React, it would have helped me so much.
Oh, thank you.
With the actual code that's out there on the docs. So.
Yeah, well, when I was figuring this stuff out, when I was keeping track of what my components were doing, I actually drew this out on paper, and so I know that you like saw me kind of struggling with copying and pasting and stuff like that, just because this is the first time I've used this Drawio app. It's from Google. But yeah, so it's important to kind of draw out or somehow visualize or somehow like figure out what's going on with information, not just how the code, like how it's kind of wrapped together, because this is how it's wrapped together. Here's the parent, and here's all the state, and here's all its children. I needed to see it like in how the information was going down. That really helped me. Okay, I'm gonna stop the screen sharing. There's no more questions.
Well,
There's a lot of chat.
yeah, people. Let's just talk. I didn't see any questions popping up, but yeah, that was really great, Chrissy. I really liked that as well. I've drawn it out on paper too. So thank you so much. We appreciate that.
Oh, thank you. You guys were so sweet.
Yeah, no, it was great, and you're really good at teaching, so that was nice. Yeah, awesome. All right, last but not least, I'm sure I'm going to say your name wrong again, but Dominika. Did I say that right?
Dominika.
Dominika. Okay.
Fine.
Dominika is now going to
Yeah.
present for us, and she's going to teach us about JamStack and show us her current site.
Are we good on time? I was gonna ask because I don't want to have people run too late because it's already 8,
Yeah.
right?
Yours was about like 20 minutes, right?
Probably, yeah, or shorter.
Okay, I think,
I'll
yeah.
go fast.
Yeah, I think that'll be perfect. Yeah.
All right. Okay, let's do this. Make sure I can share. Let me know when you guys can see it.
Yep, we can see it.
Okay. Okay. Hold on. Just want to make sure I can just like see myself so I'm not distracted.
No worries.
Okay. Back to my thing. All right. I'm just going to talk briefly about JamStack. I don't know if you guys have heard of the term before. It's pretty new. Well, this is just some notes that will help me. Wait, no, yeah, they are. Nope. What is this? Example readme? Uh-oh. I opened something funny. Okay, here are my notes. Yeah, so full disclosure about this is I am pretty new to the concept, so I'm not an expert, but this is just what I've learned and I just want to pass it on. Here we go. Okay, there we go. Yeah, I'm using like Canva to do this presentation, and it has these like very fun, distracting graphics, but I don't know if that's going to run well. But I thought we could try it out. So yeah, so what does the Jam stand for in JamStack? There is 3 things. Mostly when people talk about JamStack, they are talking about client-side JavaScript, reusable APIs, and pre-built markup. But to actually have a JamStack site, you don't need to include all of those. They might be just like very basic, built by hand sites, or with Jekyll, Hugo, or other static site generators, but the common factor that they have is that they don't depend on a web server. So when is something not a JamStack site? It's pretty much whenever a project is relying on like type coupling between client and server. And there's some examples of this, which includes like a site that has a server-side CMS like WordPress or Drupal, a monolithic server-run web app that relies on Ruby or Node or any other like backend language, and like a single app that uses isomorphic rendering to build views on the server at runtime. So what are some like benefits of making a website jam or JamStack is that you can, I guess not all the time, but the idea is to have a better, faster site so it delivers better performance, having it more secure because there is no server stuff going on, lower cost of scaling, and a better developer experience. Because I'll talk about this more actually later. And then there's some best practices that they recommend in order to be actually considered Jamstack. Some of them are having your project on a CDN, which is a content delivery network, hosted by a CDN. Also be using automated builds and atomic deploys, having everything living in Git, and using modern build tools as well as instant cache invalidation. Here I put some stuff that will help you get started making a Jamstack site. But pretty much you just need a content management system, usually like a headless CMS, a static site generator, and then that host and with content delivery network. So the stuff that I've used to build a project with this is GitHub to store my code. Netlify is my host that also is a CDN. And Netlify CMS is just the content management that's open source. And then Gatsby is a static site generator. Over here, I just wanted to portray that there's many tools out there that could do this job to build a Jamstack site. I'm trying to think if we talked about them. I was I was like trying to like actually look up if like Docker was on here, but it's not. But yeah, there's like many static site generators that use like, I think the other generators use different stuff within themselves. For example, Gatsby uses like Webpack and Yarn and other things. But yeah, there's definitely a lot more out there. And also GraphQL is listed as a backend, which Gatsby also uses actually. These are some good sources, and I can share these slides because I made the links clickable. But most of the stuff I've mentioned actually I got from here. And this is my project that I made. I think last time, I don't know if everyone was there, but I also showed it last time. But it's pretty neat. I guess I wanted to say that I was able to create this with just those 4 tools, with having not a lot of like web development experience, and make it look really nice and act very fast or run very fast. And what else I wanted to say? Oh, and using like Netlify to like, that was my first time using Netlify, which I'm not sure if everyone's familiar with it, but it's pretty fun. It does a lot for you. It can host your website for free. It makes the rendering very fast. They say that, you know, if someone, because they're like a CDN kind of host, that if someone on the other side of the world opened this site, it in theory is supposed to open just as fast as I'm opening it or I'm experiencing it. So yeah, those were just some of the things I wanted to explore, but I mainly wanted to check it out for like, you know, efficiency and and just like discover this new tech. But yeah, if you guys have any questions about this, pretty. Oh, thanks. I can talk about it more. Another fun thing that Netlify does for you is it will catch like the content or the data someone will enter in the form we created, and you can set it up in Netlify where it will send an email to you or to your client, which is very nice. But yeah, it was pretty fun. It was pretty quick to make this too, and it was interesting that there was no like web server stuff going on. So that's pretty much my TLDR on JamStack stuff. I recommend checking it out because it's pretty fun. And that's it. And if you guys have any questions, I'll take some. I was way faster. Oh, 7 minutes. Nice.
Nice.
But yeah.
I got a quick question.
Yeah.
Do you have any what other projects do you have planned using JamStack?
I think I'm going to build my portfolio with it. That's as far as I got, because this is like just like a side project I'm doing, kind of for I'm part of like the Women Who Code Boulder Denver group as well, because I just moved from there. So I'm kind of working on the side for this, but like in my day job, I actually do like I work with like avionics software, so I don't have too much time to make stuff apart, unless it's super fun. But yeah, this has been pretty fun. So probably just a portfolio site for now. There's some pitfalls, I guess, to JamStack stuff, and that is that if you need a site that does like real-time updates, this might not be the best approach. And some people say that like the scaling can get kind of complex if you need it to scale. So I think for also, yeah, I was going to mention that like real-time updates, or I was trying to think of examples of like why you might not want this, and it's pretty much everything that wouldn't vibe well with like a static site generator, or if it's just more complex. But yeah, I do like that it works pretty fast, and there's not a lot of like stuff you have to do on your end to like set it up to get going, which is nice. But yeah, did I answer your question?
Thank you.
Mm-hmm.
And it looks like
messages.
Yeah, I was just gonna say like there's some messages in there.
Will you explain more what JamStack is and what it does? It's just like it's a term for like an architecture. Actually, here, I'll click on those links I was telling you about. So it's just a way of, someone coined the term, which was Netlify, the people from Netlify, but it's like a way to follow, to build like a specific type of like static site, really. So if you ever hear the term, they're just talking about like a way of building websites, really. Yeah. Oh, the other headers I find. Okay. Yeah, JamStack is essentially a concept, not a service. Connecting to databases. So I didn't have to do that for my project. But I imagine you can connect somehow. Do they talk about it in here? Maybe in best practices, for example. Oh, so here's some examples of like who's using JamStack to build
I imagine you can create a database because I saw like a store that someone set up with it, and I can't find it anymore. But I think a lot of people, like this Sphero, I think it's a store where you can buy like STEM stuff for kids. And I'm sure they're using a database, or they have to because they take like payments and such. So I know it works. I just don't know how, because I particularly I haven't had to implement one yet. Maybe my next talk. Maybe I'll have to do a database.
Well, sweet.
Yeah.
Cool. Thank you so much.
Yep.
Awesome. Well, that was all the presenters we had for tonight. So unless anybody else has anything else they want to bring up, I'll go ahead and say good night to everybody, and we'll post any future meetups on meetup.com, and we'll keep you guys up to date, and we'll see you guys next time. Thanks, everybody. Bye.